Hello, my name is Louis Sapia, and today we're going to discuss machine learning specific to supervised versus unsupervised machine learning. Our objectives are to understand the difference between supervised and unsupervised learning and explore real-world examples using those types of learning. We want to be able to visualize in the clustering and classification in action and discuss when and where to use each of these types of learning models. Supervised learning, well, that's when you want to predict something specific. For example, will a customer buy something, true or false? Well, what's the price of a house based on the information and input we provided? Is that a cat, dog image, or is it a wolf? Is it a giraffe? Supervised learning means we are giving it labeled data, both input and the result that we expect. We provide the label that will be the result. So input data is paired with the correct output data. Let's take on classification supervised learning. This is where we want uh, the result to be a classification of sorts. In this picture here, what we see is raw data full of fruits. If we feed that through an algorithm, it will take all the inputs of it, the red, round, being an apple, green, an oval shape would be a pear, and strawberry would be small. So it goes through the algorithm and classifies it accordingly to the proper fruit that it is. An example in real life would be spam detection. So any email that comes to you, there's a model that will determine whether that is a spam type of email or not, based on the wording that's in there. Image recognition, as we mentioned earlier, a cat or a dog. Disease diagnosis is very important. All the symptoms that's inputted into the model, it could then classify whether it's a positive or negative situation for a disease. And risk, auto insurance, for example, is someone at a risk, at high risk or low risk. Let's take that as a business analogy, that auto insurance classification. Here we have ages, driving record, and claims history as our input. We provide the classification, the labeled classification, as you can see. So at age 45 with a clean driving record and zero claims, we say, well, that's a low risk. And we identify age 23, two tickets, one claim as a high risk, and so on and so forth. So these inputs are also called features. So we feed the model features to help to have it determine what class we want it to have based on those features. What we do is we use training data in order to train the models. We have to get that algorithm to work according to the data that we want to produce the results we want. Once we have that trained model, once we understand and tested that that model works, we can put it out to production for others to use in a production environment. So for example, it can predict for us if I feed it age 27, one driving ticket, and zero claims history, we predict it to be a high risk here. So how is that done? I'm not going to go too deep into programming because we're going to do that later on in the semester. Well, I want to keep focused on our concept here. So, very briefly, what we have are some libraries that we use with Python to help classify, to make those decisions for us. I have what's called here my input data. So you age 45 and and 0, 23 and 2, 30 and 1, and 50 and 0. And I'm going to have a variable hold that data for me. I'm going to call it xtrain. My ytrain variable provides the results, what I expect from results having those input values. Why are the results numbers rather than low risk, high risk? Because the model needs numbers to work. It can't work with words. So these numbers will represent the names of the classification of low risk and high risk, and we'll convert that later on in the program. So if we look at this 0 here represents a low risk for age 45 and 0 tickets. This one here represents a high risk for 23 and 2 tickets. This one again represents high risk for 30 and 1 and 50 and 0 tickets. So we have what we expect from the model to provide these labels, these classifications for us, and it works through the model. It uses the decision tree classifier library. It fits it. In other words, what we're doing when it fits it, it's correlating the input with the output so that it understands that it learns how to that these classifications match up with the input. Now we can test it by giving it the data age 23 and 2, and then we predict it. We have the model predict this information for us. And here I decipher what the 0 means, it's low risk, and what the 1 means, high risk. And based on deciphering that, I can print the result of the prediction. And in this case, 23 and 2 is a high risk. What I'm doing here, as I'm satisfied with the testing that it was trained properly, I use the function dump, which says save this model, and I'm saving it as the name of insurance risk model.joblive. Once I do that, then the business can come and use that model to do their predictions as necessary. Here is the model for them, and we load that insurance risk model.jobs live that we created for them, and then we feed it numbers. They're free to feed it numbers 50 and 0, do the prediction, and in this case 50 and 0 gives me a low risk. And that's how the program works to provide the prediction for us in Classify. We also have something called supervised linear regression. For example, it uses continuous numerous values. So it finds the relationship between our target, which is the classification, the target or output, and the relationship with this independent variable, which is the input that we provide. So let's say we're trying to predict a risk level by age and by tickets and how much of an annual premium that would be. So what we're doing here, we feed it the input data, and this is the results that we wanted to classify as. So $800 for 45 age and 0 tickets, $1,600 for 23 years of age and 2 tickets, and so on. And then what it can do is provide a prediction of what the insurance cost should be. Now, I have someone here, age 27, 1 ticket, and the prediction is 1334.36. But you might say, wait a minute, you don't have an age 27 and 1 ticket here. No, but let's find out how the computer predicted that. So this is called linear regression. The model finds a pattern in numbers and draws a line through it. Once that line is drawn, the computer can guess what will happen for new numbers that we presented. So here we have the blue dots, the training data. This is the training data, see? That's how we trained it with, okay? And then that red line, based on that training data, represents the number of tickets. And in this case, it's 1. So using the training data that we gave it, the 1 and the ages, it determines where to put that line. And then the green dot represents the age we gave it, age 27 with 1 ticket. And here's where it ends up and provides that 1253.45 premium value. We have a number of regression models that we're going to go through later on in the semester. And these are just some of them. We have the tree-based models, k-nearest neighbors models, and support vector. But we won't reach all that. For today, we really just want to understand supervised and unsupervised, their differences with one another. So let's jump to unsupervised. Unsupervised learning is used when you want to explore the data, the data and group it and find hidden patterns that you don't know about. We don't know what the classification is. We're not telling it what the classification is. We're hoping that the model will go through the data, cluster it, and we can determine once we see where it clusters, how to classify it. So we're going to have the model help us determine the classifications. So unsupervised machine learning, we provide the input, the age, the tickets, the claims, but we don't label the output. We don't do supervision here. Unsupervised, it learns from the input, finds patterns, and then clusters those. In this situation, we have driver, for input, we have the driver age, the number of tickets, and the number of claims. The x-axis equals the number of tickets, and the y-axis equals the number of claims. So what we're going to see is the X, it clusters in two ways. The X is 0, which means it's very low risk, and the X that is, or that's a blue X, that's 0. The green X is 1, and you can see where it's scattered at number of tickets, it's higher as opposed to the X, which is 0 tickets, or the blue X, that's 0 tickets. So that does show us that fewer tickets are with the blue, more tickets are with the green. So if we can look at this 4500, we can see drivers 1 is here, and as well as 4, it's very low. Let's see the fourth one, 1, 2, 3, 4, 5000, so it ends up here. Let's look at 23, 2, and 1. That is driver 2, and they are right here. So they're at a higher number of claims, of course, as we can see that. Okay. So with unsupervised machine learning results, we saw that the driver 1 was age 45, driver 4 was 50, and the older driver had 0 tickets, driver 1 and driver 40, age 45 had 0 tickets as well. So they're in the blue area, and driver 2 and 6 were in the risky area, where with number of tickets. So what do? We derive meaning from this. So we see older drivers, fewer infractions, low risk. We can classify it now. We have an idea by looking at this. We didn't tell it to classify it, but now that it's showing these clusters for me, I can better much classify it. The younger drivers, more issues, high risk group. And so that's what I'm seeing. That's what this is telling me. So the younger the driver, the higher the risk. Here we have age 22. Okay. So why use supervised learning? Well, there are reasons for learning. You might have only the raw data, and again, you're not sure what to classify. What categories do we have? You want to discover hidden patterns, for example. Unsure what you're looking for. Don't really know. Let me feed this data and see what the computer does, and find maybe anomalies that don't make sense. Well, in this situation, we're trying to determine for a store where our customers are spending, which age group and how they're spending. So here we have a customer age and the spending score. And we can see the younger they are, the higher their spending. And the middle age is somewhere in the middle, and the older age is down here, spending a lot less. So what does that tell us? As a store owner, that might say, let me put more shelf space for younger people. Let me have more items for them, since they're my buyers. Or it could mean, geez, I'd like to attract more older workers. What can I do with my shelf space to attract them? So it all depends where you want to go with. The business owner wants to go with that data, but it's very important to know who your market is this way, and this is very telling. So of course now I can label it young buyers, mid-age buyers, and older buyers. So that allows me to classify it on these clusters that I see there. This is very interesting. This is a COVID-19 ICU mortality result. This was given by ICU Hospital University in Spain. Now, phenotype refers to the genetic makeup and environmental factors. So we can see here there's a bunch of input here for these clusters that it's given. So it's between genetic makeup and the environment. So here we see three groups actually. So we see a mild up here in the red, a moderate here in the green, and a severe in the blue. So what I would do now if I'm looking at this and I see these clusters like that, let me see what's going on. So I can see, I'm going to look at some of the input. I'm going to start at the bottom. Myocardial dysfunction, I'm assuming DYS is. So here we have that these people have that. Here they don't have it. Here they don't have it. So in the severe does have it. AKI, no KI here, no AKI here either, no AKI here, and no AKI there. And they have shock. They have shock here, no shock there. So now we can start seeing the pattern is mild there. So while this so far has none of the three symptoms we just mentioned, this had one of the symptoms we just mentioned, and this had all three, and we can see why we're leaning towards severity in that group. And so now the doctors or medical people who are viewing this can categorize this as they did with mild, moderate, and severe, and recognize which patients are in danger so that they can better treat them. And so as a summary for our supervised and unsupervised presentation, your supervised classification, you input the data as well as the label, as well as the classification. And you, for example, give it high, low risk. It outputs that classification for you. In supervised regression, you provide, again, the input data and the associated amount, the classification, which in this case is the amount, the output. So the model will learn to predict that cost for you. In unsupervised learning, clustering. The clustering is, we don't provide it any labels. We don't provide it a classification. The clustering helps us determine what type of classification or label to give it, right? Because it groups similar drivers or similar symptoms and outputs those clusters for us to see. That is the end of our lesson. I hope you've enjoyed as much as I have. And if you have any questions, please contact me. Next session, we program some of this. Thanks all. Bye-bye.